Okay, so we are in where a lot of cool stuff happens right now with Lenny, and we are gonna make a nozzle, okay? Things are gonna get real technical, but it's gonna be really good, and you're gonna hear Lenny nerd out, which is always fun to listen to. So tell us what's going on.
All right, so what we're gonna do, we're gonna build a nozzle for the 03, 04, 305 horse early bowl, like small bowl, Cummins 5.9. Now, this comes from the factory at 143 degrees spray angle. We've got the machine set up at 71,500 per side, so that's going to be 143 degree spray angle. And if I go, I'm going to EDM with the corrects. I've got everything right. So we've taken the liberty to kind of get ahead. We've got a blank, so there's no holes in this whatsoever. It flows 0 liters per air. It flows absolutely nothing. There's not a hole in this at all.
And whose nozzle is that?
Well, this is one that we have made for us, and ultimately they come out of Italy. They come here as blanks. We buy them in great big lots. And what's cool about this is everything with this 4mm needle valve with this size sack. We can use this for Duramax. We can use it for Cummins, all sorts of different applications at different angles. So this same nozzle can fit, well, at least a half dozen different trucks in different. So I can buy hundreds of these at once, and that gives me the playground to do whatever I want with whatever hole count I want, whatever hole diameter, and I'm not having to chase factory hole counts already. So it's a perfectly clean canvas to start out with and make a perfect part. So
awesome.
We're gonna start. We're gonna do. This is gonna end up being 143 degree spray angle. Exit out of that. Now, what I've chosen here is a piece of wire that's 0082 thou in diameter, and that's the wire. So it's 8 thou 2/10. Super small stuff. This thing is programmed to come down in. We want it to be as close to that nozzle as possible without colliding into the nozzle, because this little piece of wire has some flexibility to it. And if we pull too far back and we start EDMing, it starts to whip around and it makes a really ugly hole that isn't very circular, and we don't want that at all. You'll see that later on. I'll show you some of the other stuff that other people do, but part of our pride is in how tight we bring that into that part. Now, not every one of these parts is made the exact same, so we can't just come in there within 2 or 3 or 4 thou, because the next piece, that machine's gonna come in there and collide with it, so we give ourselves like 15, 20 thou.
So quick, for those that don't know, what is EDM?
Electro discharge machining. So ultimately what's gonna happen is that piece of wire is gonna get charged off of that contact block. That guide is holding the wire with a lot of precision. This thing right here, that's just a big chunk of tool steel. Part of this thing's precision and accuracy is the fact that this machine is so bloody heavy that when people are working around us, the machine doesn't know that, and it's not wiggling and vibrating around. So this machine, there's an old man named George. He was very surprised because we were able to burn some wire clear down to 3/1000ths of an inch, which is actually smaller than like the human hair. And we're able to hold that accurately and start burning holes. So he was super excited because he made this machine, and he's been making machines since like 1970. This was the very first machine that he's actually made that was capable of running that piece down to 3/1000 of an inch. And the reason that's cool is because a bunch of these like really high pressure systems are using very, very small orifices now. So we're able to do all sorts of emissions things and whatnot. That's really cool. We've got a patent on some pilot technology. So we'll use wire that's like 2 thou 7/10. And with the overburn, because that water that we're seeing, that water is actually what's doing the burning through the nozzle. And ultimately, this piece of tungsten gets charged. 100 megohm worth of resistance is what that water is. And the machine, I know that because the machine is programmed, runs through a filter and a bunch of crystals, and it comes out at 100 megohm. That is the exact resistance that this program is set to run and give us a really clean, accurate hole. So this, like I say, 143 degree spray angle. You can see where the angle is going to be. This is going to be a 6-hole platform, which is really, it's about the most efficient that we've found for this style of bowl. And this is going to be just a 305-250. And we're going to flow it with air here in a minute. It's going to be under 40 liters of air per minute. I'm going to measure the hole diameter here in just a second, just to show you. And because a lot of guys like to talk in hole diameter and they want to talk in percentage over. I'm not a real big fan of either one of those two. Those two talks, those two ways of speaking about it, because tires don't care about hole diameter.
No.
Tires don't care about percentage over. Tires care about like cc's of burnt fluid that hits the piston, makes the piston go down with lots and lots and lots of violence. That's what tires care about. So if you're buying something to be super efficient, you want the injector on time to be as accurate as possible. So we're going to look at something else called rate shape, which Skylar's going to show us in a little bit. Skylar's going to show us how this, without running any abrasive flow machine through it, is kind of a garbage part. And we're going to show you that on camera. We're going to run it on a body. We're not going to be satisfied with it, and then we're going to hand it off to Adrian. And then Adrian's going to put it on the AFM abrasive flow machining, and he'll get it to 40 liters per minute, which we've got several different machines around here that measure that. And ultimately 40 isn't a dictating factor on power either. That's literally just like going up 12 rungs on the ladder. Well, if you go up 13 the next day, you went up higher. Okay, so we will air around microphones, always fun, right?
Yeah.
Unfortunately, it's part of the process. Okay, so bear in mind that nozzle is going to be sitting inside of an injector, and it's going to spray fluid from here out to this bowl, and the flame's going to recurve, and then boom, piston's going to be forced down. With piston coming up and then piston being forced back down by the explosion, there's virtually zero dwell time. So we want everything on and off as accurately as possible, and all of these super high dollar machines are part of that process, and they all have to work together to make it happen. So we've got, which is kind of funny because this like $400 tool, who people have made fun of us forever, on this flow meter it's like 36, almost 37 liters of air per minute. We're barely gonna have to touch that to get up to 40. Now we're gonna get in on here. We will focus in on that hole.
Oh, that's cool.
So you see how that is very, very, very round, right? Now just to prove how round that hole is and what the hole diameter is, this super cool machine does other things too. So if I go here and I touch it right here, booyah, you see the red dots? You see how that's just a perfect circle of red dots? If there's any deformation in that hole, those red dots will follow the deformation, or the red dots won't even appear. So with one click, that's awesome. Sometimes you got to click 3 or 4 times on some of the other guys' work. And now that hole is 10 thou and 7/10 of 1 inch. So could I say that's an 11 thou hole? Could I say it's a 10 thou hole? We don't talk that way, so we don't call it anything like that. But that's 6 at 10 thou 7/10. This thing measures so accurately, like if I check another hole, it might be 10 thou 6, 10 thou 8. So it's super accurate. But now, like, we've got our DLC coated needle valves. We will put this together. We will hand this off to Skylar, let him put it in our new test stand. We'll look at rate shape and cc's delivered. And like I say, it's not going to be what we're after, so then we'll bring it back over and show it to Adrian.
All right.
Next step, we're
do it.
going. All right, Ben, so right now Skylar's going ahead and he's putting that nozzle that you and I just EDM'd, 143 degree spray pattern. It's like 10 thou 7/10, under 40 liters of air per minute. He's putting that nozzle on a factory calibrated body. That nozzle is EDM'd only. If you put them in a truck, they would make more power than stock. But here in a minute, when he starts that machine up, it's going to get noisy. So we kind of have to do this talk right now. He's going to run that at 1700 microseconds and at 160 MPa, or 1600 bar. Same thing, but 2 different lingos. And we're going to expect to see X amount of cc's out of it, and we're going to expect to see the rate shape looking really aggressive on and really aggressive off. And it won't do that. It's going to be a little bit lazy. It's going to be a little bit ugly. And those are the things that I wanted to show you, because when somebody says, well, so-and-so's EDM and parts are so-and-so, and they rip, they might make a bunch of power because the hole size is so bloody big, but the body can only support X amount of like cc's delivered. And ultimately, we're trying to make that as efficient as possible. So having 2 extrude hones and 1 AFM gives us an advantage of making sure that we get the K factor, which is the radius that feeds that hole. We want that exactly perfect. Yesterday, Skylar and Adrian had been monkeying around, and they found a recipe with K factor by dropping the media of the AFM machine. That media, when we got the thing, they told us to run it at 71 to 74 degrees. And that's the paste that basically flows through the machine, right? We discovered yesterday, running it down to 64 degrees, that it thickened up the body, and we were able to reshape the K factor to where these guys were able to make a hole 1 thou and 3/10 smaller party with a bigger hole. 1 thou and 3/10 is a big jump when you're talking in thousands. But they discovered that they got it to actually work even better, because the smaller the hole, the better the atomization, the better the drivability, the better the fuel consumption is going to be. And these guys were able to just work on that K factor and get that. So that's the kind of stuff that we're always constantly doing. And it's really hard to talk about that with people because it's happening every 4 hours.
Yeah.
You can sit down at lunch and be like, wow, this morning was blah, 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 blah. And after work, you can be like, man, today we learned blah, blah, blah this afternoon. So constantly, with as many guys we got in here and as many cool machines we got, it's constant, steady learning. It's awesome. Love it.
That's really cool. The fact that you've got guys here that have the willpower, the knowledge, and they want to mess around with things and try and find every little last piece and make it better.
Yeah.
That is what blows my mind, because I feel like no one's doing that right now. No one cares to.
The culture in what we have here, like earlier today, I was talking to another guy from another company, and I looked at Jeff Franks, who was out there getting ready to laser some injectors, and I go, Jeff, what's your tightest deviation in one set? And he looks at me and goes, Skylar's got me beat, but it's 0.23%. Like, he had 6 injectors balanced within 0.25% basically, and he's like, yeah, Skylar's got me beat. So that's, we're always playing games like that to try and like one up each other, and it's just a culture. Like, that's just kind of how we roll around here, and it's a lot of fun to be with these people. That's
true. Touch on one more thing there. So you said you got them balanced within how close to each other?
0.25% within 6 injectors.
Okay, and what's like factory?
On the big end like that, 18 to 20%. 20, yeah.
Yeah.
And that would give you a green check mark. Yeah, and that would be something that like an OEM truck you'd start. I would get in it and want to kill myself just listening to your garbage, but that's because I'm trained to listen to all that stuff. The poor ECM, like, it's trying to get those injectors to run the same, and it physically can't. Like, there's not enough time between shots for the ECM to recorrect. So just the more time you spend on calibrating the injectors, the more time you spend on calibrating the nozzles, that just makes the rest of this process go way better. So example, like when we're doing nozzles the way we're doing them now on the new AFM, how many adjustments do you have to do once we get calibration of a set of injectors now takes, compared to the old days?
I mean, like starting on that on the EDM,
Yeah.
like getting the holes orientated properly. I mean, we can do 3 or 4 adjustments before we get it perfectly how we want it.
And once we get the nozzle perfect and the AFM work perfect, to come down here and calibrate them, how long does it take to calibrate a set now?
It's a lot easier. Like everything, like we bolt them on. Sometimes we don't have to adjust 2 injectors, 1 injector. Sometimes we don't have to adjust a single injector to get within 2% with getting everything perfectly accurate down there now.
So what he's saying is sometimes he doesn't have to adjust any of the 6 injectors, because the way we're measuring the inside shelf of the injector body, that gives us like a computed stack of all the different shims. They get put together dry. If we get the nozzle completely correct, sometimes they won't have to make any adjustments. And that's something that 2, 3, 4 years ago, it was an hour per set at minimum. So things have, the tools have made the efficiency a lot better, which is really good, because the more efficient we can be helps offset the costs of like some of these parts these days.
Yeah.
Everything's going up anyways, but the more we can save on labor, the less we don't have to charge the customer. And as inflation is growing, it's getting to be painful anyways.
It seems like you're really taken to heart. The old Abraham Lincoln quote, give me 6 hours to chop down a tree, I'll spend the first 4 sharpening my axe.
Truth. Yeah, that's
Your axes
actually
are
well
sharp.
put. Yeah. All right, well, Skylar, we're on this sucker. Can you show a snapshot or a screenshot of what the nozzle response time is going to be?
Yeah, I can pause it once we get.
Okay, perfect.
Out here in a minute,
See the green up there? So it's going to be 1600 is what we're after. And basically the rail in the back, it's just like a 4-power stroke. Once it sees that 1600, it's going to stay there. It's going to start measuring fluid. The bottom line on the green right there So those 3 lines are like the solenoid energizing, the holding of the solenoid, and then the rate shape. Rate shape is basically back pressure in that stainless steel line. And it's, because as the piston comes up, getting your cc's measured in there, let's just say we're looking at 204, 205 mm cube, 205 cc's. Getting that in there is fine, but once we get it in there in the correct amount of time, the motor runs way better.
Yeah.
So with this tool, what's our nozzle response time on that right there?
So from the time the solenoid was actually activated and the time we actually had fluid going to the nozzles, it's 245 US.
245 microseconds for nozzle response time, okay. And would you say, well, now, I mean, that rate shape doesn't look horrible,
No,
really.
it's not horrible. For this part, it actually runs pretty decent how
Yeah,
it is.
yeah, that's not bad.
Yeah, no, it's actually
So,
really good.
all right, so Skylar, you just ran that injector.
Yep.
The nozzle's not been run at all with any AFM or extrude hone yet.
Straight EDM work only.
Looking at that rate shape, it doesn't look horrible, but we're gonna go polish it up on the AFM and see what we get.
Yep.
What did we get for MMs cubed?
So 204.8 was our final MMs cubed on this at 1700 microseconds at 160 MPa.
So,
Factory test plan for a 5.9
so
injector.
factory test plan for a 5.9 injector. So ultimately, like if we take that 204, call it 205, and we multiply that times about 3.5-ish, because you can get about 3.5 horsepower per mm cube. You're gonna see sub 700 horsepower there. We're not gonna change the hole diameter. We're not gonna change the percentage over, but we're gonna get Skylar to pop that nozzle off the body. Just remember that we had 205, right? And then we're
205,
gonna,
count it.
205. So once we do that, we run it with just a little bit of AFM, and then we'll see what we get with something that the naked eye would never be able to see, and something that people can't really brag about. You'll see how much we gain, potential horsepower that we would gain just off a few seconds on the AFM. All right?
I'll take it. So if I was following Skylar correctly, this injector nozzle that you just made, that is basically your early version of making a nicer one, already flows better and better than stock.
That's mostly the body, because the way we calibrate our bodies is quite a bit hotter than a factory Bosch body. So that's why it's actually quicker than stock still. But here in a minute, it'll be even better. The atomization and the spray pattern of that with the EDM work only, it's gonna be okay. The atomization and spray pattern after AFM will be like craziness. And we'll show you with a borescope, well, you've seen that before.
Yeah.
So we'll show you with the borescope like before and after of AFM work. And this is gonna take such a slight amount, like it's seconds, and this thing's gonna be right at 40 LPM. But that new test stand, what's really cool about it is the way it functions is once you get the first one set, it goes, oh, that's how much you want me to flow? And then it runs all, if you're gonna do 60 of them come out within, so we've always talked in liters per minute. So imagine like 40.0 or 40.5 or 40.7 liters per minute. If we get it to where it's gonna run 40 liters per minute, it flows the nozzle as it's processing the nozzle. So it's gonna come out at 40.000. So super cool.
Yeah.
Thank you, sir.
That's it.
Nice. Okay. You're almost up, buddy. Okay, so this is that nozzle that we just made. Thanks, Adrian. So we see, I mean, it's high quality EDM work. The holes look nice and sharp and crisp. We have not, like when this one got burnt, that wire would have come over and it could have touched up here. But our programming, we've got everything set up so it won't do that. So that's
have
really,
you gotten nozzles in from other manufacturers where you can see where they poke straight through?
we will show you a bunch of garbage soon.
Okay.
Yes, we're not going to talk about who they were, but we're definitely going to show you all sorts of mistakes and all sorts of things that you could only see if you had this camera.
Gotcha.
But yeah, we'll give this thing to Adrian right now. We're going to let him Basically that rough edge right there, we just want to knock that rough edge off there and give it some sort of a chamfer to allow fluid under pressure to flow by it very quickly. But we're still not going to change the OD of that hole. So, Adrian? So this thing's it's like 36-ish, 37-ish right now. So if you throw a camera on, okay, so here in a second, he's gonna start processing and it's gonna find like how much it's flowing and it's gonna show a line, and when it gets to 40, it's gonna stop. If it eats a piece of trash in a hole, pressure spike, and it instantly stops, gives you, the operator, a chance to plug it or pin it. We're at 39.8, 39.40. So that was how much we just gave this thing flow lift on that graph right there. Super cool tool. And what's really nice is with the older style extrude hones, to do that would have taken us 7-8 minutes. You'd float for 20 seconds with media, and if it eats a piece of trash, you got to pick that piece of trash out. Then you put it back in the machine, you run it for another liter or two. So right now he's double checking that the machine did its work correctly. 40?
Like you can see, it'll hit right at 40.
Yeah.
When that ball just
Dead
touching
on.
that little line right there, comes out perfect every time. Literally, you put a part in, comes out, it's perfect.
So, you know, we've always wanted to buy as many cool tools as we could afford for whatever technology we had available. And this is just new technology, super expensive. But how many parts have you processed on this now, you think?
I'm actually at about 13,800.
13,800 parts has been across this bench, using it half the time this year, because we still use the extrude hone on a lot of other stuff. And this thing, even though we purchased it brand new, was fairly problematic at first. So we've had to fight with this thing quite a little bit. And now that we're getting it, you know, like every day we're getting it smoother and better, better. But yeah, he's ran 13,800 parts on this thing already, this year already. And that tool showed up in January or February. So before, obviously we didn't force something through something and make it go smaller. But before, just because of some of the metal shards that were in there from the EDM work, it saw that and it was, you know, basically it's microscopic flares of metal. And it was showing us that it was a 10 thou 7/10 hole before, right? And now that we've cleaned all that garbage out of there, this is now a truthfully nice round, clean 10 thou 3/10 hole. So technically, do we make the hole smaller? No, but our measurement's more accurate now, but we're off by 4/10 of 1,000ths. So all we did was shove, what, 10 seconds worth of AFM through it? Now let's go over to the other bore scope and we'll show you what the K-factor looks like inside there.
Okay.
Pretty cool, huh?
This is the next camera is my favorite one.
Guys, thanks for staying. So
These holes look different.
they do look different, don't they? This is actually kind of, you know, it's really cool to do this because having the tool was one thing, buying the chiller was another thing, and getting the chiller dialed into that media, which we've had 5 different batches of media this year, and all the media, it's like going to a body shop and looking at sandpaper, different grits for different jobs. The media at different temperatures, we're learning that it does different things to different hole diameters. So trying to find this art and trying to become like a real craftsman of this, it's not like everybody, when you go to Cummins, they're gonna have extrude hone or whoever they're working with set up a program and go, look, we're gonna pump 6,000 parts out a day. And that exact part with those exact same hole sizes are gonna get done with that exact same style of media, same temperature, and it's just repeat, repeat, repeat. None of our customers are gonna buy 6,000 parts in a day.
Right.
So our art is learning how to go from 4,000ths to 25,000ths and make those holes look like that all the time. It's not that easy. So now that you can see we've got just a little chamfer on the inside, It's taken us just a few seconds to do that. A really expensive set of tools to do it, but let's take it down there and we're gonna go ahead and run it in the stand and see what it pumps. We used to pump 205, right? So we'll see what we get.
The one other thing I want to point out here is we saw the picture earlier. We know that the hole is technically smaller, but if you're looking at this picture and you didn't see the previous one, these holes may look bigger. They're not actually bigger.
All we're doing is putting just a radius right there, and that radius will change all of your gas testing. It changes the CCs delivered. It's going to change a lot, even though that's something that technically nobody else on the planet is ever going to look inside their nozzle to see. These are the tools that we have to use for today's emissions. When you're building something with a diesel particulate filter, the last thing you want to do is hurt the DPF or shorten its life. When you're building something, the last thing I want to see is any of my customers out rolling coal and just wasting money. And at $5.50 a gallon right now, who can afford to do it?
Yeah.
Like, people got to get to work, they got to get home, they got to get to work, they got to get home. And these types of things optimize all of that stuff. So we're just, technology-wise, we're just trying to consume as much technology as we can and then learn how to use it the best we can to give people the best parts possible.
Yeah. So if you're looking at the old picture compared to this one, you're seeing that shiny part.
Yep.
That's the radius.
Now, technically, that's called K-factor. And literally, we've done basically zero work to make that hole any bigger. We're just pushing that little radius right there, and that's all we're doing with that process.
Sweet. K-factor.
You excited to see what it's going to do in the test stand?
Yeah, I am.
I am.
I'm actually pretty stoked. Hey-o.
And I do have some.
All right, so Ben, a minute ago, we saw this thing pumping 205 mm cubed or 205 cc's. Right now it's pumping 260, the exact same test parameters. And let's just assume that you're gonna make about 3, depending on the efficiency of your motor, your cylinder head, you know, all the intercooler, turbocharger, all of it, right? Based on that efficiency, let's say we get 3.5 horsepower per mm cube. So, what's that?
913.
All right, so thanks, Skyler, appreciate it. At 205, we're able to get about 717.5 horsepower out of that nozzle the way it was. And now we're at 9 what?
913.5.
Now we're at 913.5. So we just gained 200 horsepower with 10 seconds of Adrian's work, a little bit of radius. What's the response time? Look at that rate shape, super steep.
Yeah, so it's a lot steeper than it was before, and we actually picked up on nozzle response time about another 5 microseconds what we picked up, so we're like 240 instead of 245.
So that is exactly, prior to us having rate shape, oftentimes we would send out an injector that was so fast, but we couldn't tell somebody how fast it was. Tuning for them became kind of a nightmare.
Right.
Because now they're having to, advance timing and retard timing to get the injector to fire on time, right? Well, now that we know, we always want to be like 40, 50 microseconds faster than stock. So we basically bring up our nozzle size and our body size to match. So we're always kind of a little bit faster than stock, but not crazy faster than stock. It makes the tuning of these things a lot simpler for everybody that's out there trying to get these things dialed in. And with just, handing out on our website, we've got the flow sheets for everything except for the custom stuff. If we send you custom stuff, that flow sheet is the one. Do not lose that.
That's yours.
That is yours. That is not a standard off-the-shelf part. That is your custom part, which we do custom parts all the time. Matter of fact, yesterday we had a guy call in. Basically, he took his 5.9 from like 2005, which would have had 124 degree spray pattern, and he put a 6.7 motor in it with 6.7 style pistons. Everybody else on the planet would say that 143 degree spray angle is the closest we can get you on a 5.9 body, which is actually true. But with us, starting from blanks, the 6.7 piston requires, technically, 146 degree spray pattern. So we made him a 146 degree nozzle with the 5.9 style body to go 5.9 ECM, 5.9 injectors, 6.7 long block in his 05 truck. And it's a complete perfect match.
Well, and that's because you have the ability to start with a blank nozzle.
All in-house, baby. Yeah.
Yes.
All right, Skyler. So how about you chuck a big nozzle on a stock body? So the experiment here.
Before I do that, you guys look at the graph. Solenoid actuation, So we're pretty much full feel before the solenoid even shuts off, and then obviously there's always going to be a delay for the parts inside. So it's shutting off fairly quick within.
So this is the kind of stuff that we just didn't have before, and basically nobody really in the U.S. has this technology yet.
2.4 is it's fully off. So now we can compare this to that one with the big nozzle.
Okay, so you're saying full off is in how much time?
2.469.
2.469 microseconds.
Yeah. Well,
So-
no, like 2,000. Like it's 2,000. Like 2,400.
2,400
Yes.
micro.
Yes. Because when we go from
Yeah,
2,400.
yeah. It's all the zeros that gets me all goofed up.
Yeah.
But basically, we want it on and we want it off instantly. So the piston sees fuel instantly, and the piston, like it shuts itself off. We don't want like a tail dragger. We don't want to chase the piston down the hole, and we don't want it to be lazy coming in. It's just the faster we can get it in, the faster we can get it off, the more precise the injection is going to be. So without having that machine, we just didn't know. And that's something that technology-wise, you know what hurts is when you hit your funny bone on the vise. Like everybody laughs except for me.
Everybody, ha 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 ha.
Yeah, that was a good one. But yeah, so having that technology is something that when we're writing recipes, we use it every single time. Once the recipe's wrote, we can go back to the standard machines and just go back to counting CCs. Unless we have an issue with something and it's not doing what it's supposed to, then we can come here and troubleshoot it with this. But ultimately, every single recipe now, you're seeing the process. EDM off a blank, extrude hone or AFM, come here, we measure rate, shape, make sure it's going to party the way it's supposed to party. Once we know what the recipe is, we know how the shim stack's set up, we know what we've got our nozzle flowing, what we've done internally to the body, which we're going to show you that in a moment. So Skylar, the nozzle that you're using right now is how many percent over?
It was a 500% over nozzle.
This is a 500% over nozzle on a stock body, right?
Correct.
Now, we know that this thing is garbage. This is smoke. This is no power.
Yeah.
But if you go to eBay and buy a 500% over,
Yeah.
you're going to get somebody's Chinese EDM'd out huge nozzle on a stock body, and you're about to see what a POS this thing is. I wish we could drive a truck like this.
Yeah.
It's oral and coal, and it doesn't go anywhere.
Yeah.
So the body just can't keep up the nozzle. The nozzle becomes so efficient at evacuating, there's nothing left in the body next.
It's at like 214, 215.
That is lazy.
Yeah.
So we're at 220 mm cubed. So if the rate shape looked correctly, that would make over 700 horsepower. But what's our, oh my Lord, that's horrible.
So basically, the full fuel's not even happening until the solenoid's off. That's how slow it is. The solenoid's
Wow.
off, or is shutting off, but we're still not getting full fuel till.
So that red line is solenoid being told to
this is-
close.
Yep, solenoid
And
closed,
it's so lazy because the body's so empty that it's not even getting to full fuel till after the solenoid's told. So it's
we're
chasing
still
the piston
like
down the hole.
130 microseconds after solenoid's closed getting full fuel.
Yeah. So
And
so
then-
this is the kind of thing that without having this super cool tool, we would never be able to see that. Does it pump? Well, yeah, it's a 500% over nozzle
Yeah.
on a stock body. And mathematically, 219, grab my handy dandy iPhone because I can't do math. So if we take 219 times 3.5, mathematically that's 766 horsepower worth of fuel. But to get that fluid in there, it needs to come in right now and shut off right now. That is not happening. So
It amazes me that there are probably some people out there that have bought these nozzles before and are under the impression that they have to have a 500% over nozzle to make 766 horsepower.
and well, this truck would just run horrible.
Yeah.
This would be a hot, smoky turd that got horrible fuel economy. The tuner would hate himself. The tuner would hate the buyer. This just would not work. So
This is, on the podcast, this is the guy that calls in and talks to us. I bought this truck It's got a single 475. It's smoky as hell. I'm trying to tow my landscaping trailer. That's him.
Here's your sign.
Here's your sign.
All right, well, Skylar, can you do me a favor and swap that to a body that's calibrated for that? And then let's see what it looks like. It'll be a whole new world.
100 US slower than a stock injector too
100 US slower than a stock injector
for reaction.
for on time. So it's told fire, and the nozzle's so big it evacuated the previous shot already. So it's 100 microseconds slower. Instead of being 40 or 50 faster, it's 150 seconds late. So when your tuner says, you know, I'm going to give you 1,000 microseconds at 220 MPa or whatever, this already puts us really far in the hole. Our timing's going to be way far off. It's going to be way far retarded, and the injector's just never going to run right.
Well, and there's virtually no way to clean it up.
Well, there is. You simply take that nozzle and you put it on a hopped up body,
Yeah.
and then you calibrate it, and then it's cleaned right up. In the truck, tuning the truck, you'd never get that fixed.
No.
Having all these cool tools has just helped us. You know, Skylar basically specializes in designing the hot rod recipes now. And when I say hot rod, I don't necessarily mean that. Like, he's also working on the stuff for like the EO testing and all that stuff, trying to make stuff just on off and as fast, as clean as possible, even for like the Eco Series stuff, which is going to be like all EO tested. So he's working on designing the recipes for that. And there's times that him and I argue over wire diameter within a 1/10 of a thousandth of an inch. Like, he's like, I want to use a 6.4. And I'm like, but it needs a 6.3 because we got to run a bit more AFM through it. We're arguing over 1/10 of 1,000th of 1 inch now.
Yeah.
It's kind of like being married. Like,
Okay, so this is body mod, big nozzle,
so body mod number what? Like a 15?
15.
15 body mod. Now, is this still going to be at 1,700 or is it 1,100?
Turn down to 1,100 microseconds.
So we had this running at 1,700 US.
Yes.
Now we're going to shorten the duration or injector on time down to 1,100 because if we try and run this, which an injector this size would never actually be in a truck that somebody tunes to 1,700 microseconds. An injector this size is going to be in something that's going to be in something with an S500 or a GT55 on the manifold with lots of engine RPM and piston speed that's so fast there's zero dwell time. You don't have enough time to shove 1,700 microseconds in it and make it work correctly. You're going to be down in the truck. You're going to be in 900 to 1,200 US is all the injector on time is going to be at 5,500 engine RPM. And besides, if we tried to run this injector with 1,700 microseconds, it'd probably pump what, 700, 800.
It'd be 700, 800 is.
And that kind of fluid flowing through a stock Cummins body will kill that body, like melt it. So we're not even gonna try. Like, we've tried it. That's how I know what it does. Like, the seals inside of them get destroyed.
It would last. I don't know about the testing. We'd probably break something.
I think the test stand would do it. This one,
know,
I think
I
those ones break.
I have full faith in the body.
I don't have full faith in. Let's just not try it.
All right, 1,100 it is.
This is gonna get really noisy in a second.
Just perfect air right now.
And they started hearing that noise, and he hit that red emergency button, and he goes, "What's wrong with the injector?" And I'm like, "Nothing. It'll be fine." He's like, "What do you mean it's fine?" I'm like, "Let it eat." "Are you sure?" I'm like, "Let it eat."
And the injection per minute pretty low. That's why it's so.
So you got the injection per minute cut in half.
Yeah.
So that's 2,450 horsepower. So again, we're learning tricks to keep test stands and injectors alive while calibrating. So Skylar, when we use that program, he's got it cut, the injections per minute are cut in half. So the fluid that we're counting is half. We still got 350 mm cubed out of it. So if we take 350 times our 3.15 gives us 1,225 times 2. So 2,450 horsepower worth of fuel out of that injector right now. With
That'll party.
going, and that's the same nozzle that we just had on a stock body, just the proper body mod What's our response time? You see, look at that line.
Nice, fast, quick. We're 223 microseconds for response time, reaction
Okay.
time. Stock injectors like 275. So we're
50.
Yeah,
We're 50 microseconds quicker than a stalker.
Good.
And injector off time is BAM right now.
Yeah.
The way that scope, it's picking up so many bits of time, you'll never see it straight up and straight down, but it's such a cool tool.
Yeah,
It's so
off
sharp.
time's like 500 microseconds quicker.
500 for off time.
Yes, for off time.
So shutting it off, it's 500 microseconds faster than a stock injector would have been.
Wow.
Yep.
So this, and you know, like again, we get this tool. The first thing we did was put piezos in it, which was kind of a pain because when you put a piezo in, like we've studied 5.9s to death. We've got tons of dyno time on 5.9s. Piezos, like we've got throttle plates in there, we've got nozzle modifications. The throttle plates have all sorts of different holes in them that we learned it was a very steep learning curve, but we had a customer that really needed them very badly. So we're like, all right, let's go. So we started on piezo and then we started doing the easy stuff after, but we're still learning every day. It's pretty amazing to be. It's kind of electric in here all day long, really.
Yeah. It's very exciting. Yeah. I think the facility speaks for itself too. If you look down a workbench as they leave it at night, clean when you leave, clean when you get here. I noticed the whole time you're wiping your handprint off.
Yes.
That means a lot when you're dealing with highly expensive machines making really cool parts for cool people.
Every part, like cleanliness is godliness inside an injection shop.
Totally.
And so, you know, it's like a positive air. In the summertime, we've got 8 tons worth of air conditioning in this building, and we've got half of the 5 coming in here, plus another 3.5 coming in directly into here. So this room, with all the doors closed, actually pushes the doors open all day long. So whatever dust is falling off this, it's hitting the ground, and then it's just washing out the door all day long. So it's really a nice, clean room, and it's very nice. It's very comfortable in here now, too.
Yeah.
Like even with the chiller, it disperses heat into the atmosphere. This room is always 70 or 71 degrees, like no matter what day of the year.
That's fantastic.
Consistent parts.
Yeah.
Just makes a big difference.
Well, and everything comes into play at that point. If you've got a consistent temperature inside here.
Calibration oil, the AFM fluid, the test stands. If everything's consistent, we can always count on our data.
That's awesome. Well, thank you for showing us this entire process. I knew you guys were doing really cool stuff, but being able to see it from start to finish with a nozzle is
Cool. I'm glad.
blows my mind.
Right on.
All right, Lenny, thank you so much for inviting us in and showing us the secret and the magic behind and everything. It's fantastic.
Secret's just really hard work often.
Yeah.
That's pretty much it.
Well, you're doing a good job.
New cool tools, like that helps a whole bunch. And man, I do want to say thanks for swinging by, and because we don't spend enough time trying to show people what we're doing that's a little bit different. And ultimately, like, we're trying to outspend everybody with technology and then try and learn how to use technology so it's just better. Like, we're just optimizing these tools, trying to make the best parts we can. And I really do want to appreciate you guys for just giving us the opportunity to show you that.
Yeah, absolutely. Because not only does that benefit you, benefits us, but at the end of the day, it benefits the guy buying the injectors.
That's the goal. Like, as long as everybody's really happy with the way their trucks run, you get to make some money, we get to make some money, their trucks run good, they're glad they spent the money, that's a win-win-win.
Well, right on, man. It's good to see you.
Thanks, buddy.
See you on the next one.
All right.